Question 57 is quite a long one here. It's part C that takes the most time. We'll start here. And what we've got is this little system attached by a pulley. And we've got A here with a mass of 4 kilograms. So it's got 4G pulling it down. And it's attached by a wire, so there's some tension holding it up. We've also got B. And B has got mass M, so we've got mg pulling it down, and also there's the tension there pulling it up. When it lets go, A descends with a velocity of 3/5 g. So let's look at A to start with. At A, what forces are pulling it up? No, pulling it down. It is going down, so let's see what's taking it downwards. So you've got 4g taking it down, minus the tension that's stopping it going down, and that equals its mass times by the acceleration. And so if I can rearrange that one straight down actually. I can just add the t to that side and take away, what have I got? I've got 12/5 g there. You can do it in a calculator if you want to. And so I think I've got 8/5 g there. The tension is going to be 8/5 g. Just under 16, I guess. 15.6-ish, I think. 15.7. Now look at what's happening at B. So if A is going down, then that must mean B is going up. And if B is going up, so we've got a tension pulling it up, we've got mg pulling it down, and that equals its mass, m, times its acceleration, which is 3/5 g. Well, we've already decided that this tension here is 8/5 g, and that's why I left it as g rather than changing it to a decimal. And here I've got 3/5 g times by m, so just rearranging that, actually all the g's cancel out. Add the m to, isn't m just going to be equal to 1 there, I think, isn't it? Just going to check that. Check complete. Yeah, m equals 1 kilograms. Now it's part C that takes all the time here. That what's happening, so this system here is so A is going to go down and it's going to hit the floor. While that's happening, B is going up. Once A's hit the floor, B won't stop dead there, it will keep going. It will keep going until gravity takes over, and then that will go down and hit the floor as well. So this question says, what's the highest rate we're going to go? We need 2 bits of maths here. The first bit we're going to do is, how far does it go up while they're still attached? Then we'll do this bit, the second bit for that journey there. So this is Suvat equation stuff. So we've got, so while attached, so while they're attached, the initial velocity is 0. We're going to need to know what the final velocity is. We're actually going to need to know what the distance is, but I'll do that one in a minute. We know the acceleration is 3/5 g, and they told us in the question there, although it's gone off the top, that the time is 0.6. And so v equals u plus at, v equals nothing plus a, and t, well actually I'm going to write that as a fraction as well. So the velocity here is 9/25 of g, and I have worked that out already to be about 3.5. So there's the velocity at the end while it's still attached. Let's also work out the distance while it's still attached as well. So I'm going to do an s equals ut plus half at squared there. So s equals nothing plus a half times a times t squared. And that works out to be 1.0584. Right, let's just go back to the thinking again here, and I know the video's going on a bit now. So this is 1.0584 meters. It does that while it's going down. It also does that while it's going up as well. At that point there now, at this point here, It's now going to keep going up for a little bit longer. We need to figure out now what that little bit longer is. So it says free moving now. So at the start of the free moving part, the initial velocity, that's why I did that earlier, the initial velocity at the end of that is what stopped being there. The final velocity, we want to know when it reaches the top of this motion, so the final velocity we want there is 0. We want to know what s is. We don't know what t is. We do know what the acceleration is now. Now there's no wire attached to this anymore, it's just being used gravity, so we've got minus g pulling it downwards there. S equals ut, no, not s equals ut, v squared equals u squared plus 2as. I don't want to go wrong after 6 minutes of v squared equals u squared plus 2as. So I've got nothing equals 9 over 25 g squared plus 2 times minus g times s. That gives me a distance for this bit here of 0.635 meters. The grand total distance is, so it went, that was 1.0584, it's then gone up 1.0584, and then it's gone up an extra 0.635 meters. The grand total of all of that is 2.75 meters. Sorry the video's gone on so long.